Hi. So I'd like to just give you a quick overview of the basics of building a scikit-learn machine learning model. So the nice thing with scikit-learn is it's very uniform. It's a very nicely integrated package. So once you know how to make one model or do the code for one model, you actually know how to do the code and run lots of different models. So that's really great. So let's just go through one example of that workflow, and hopefully you'll catch on and you'll be able to try lots of models. So just to emphasize the point, I've already talked about this in a previous demo, but we're going to start with splitting the data set, but we're also going to convert it to NumPy arrays. So we're going to create a label array using numpy.array from the column in the pandas data frame. We're going to create an index that we use the train test split method on, and then we can get an X train, which is our training features, a Y train, which is our subsample of training labels, notice using the same index, and then we get an X test and a Y test, and which we'll use for testing. And notice also we have to do this ravel here to make sure that we get the right dimensions for our label NumPy arrays. And it's important, the reason I'm emphasizing this is you cannot use pandas data frames with scikit-learn. It must be NumPy arrays, and they must be correctly dimensioned. And we've already talked about scaling, so I'm just going to breeze through that, but we're just going to use the preprocessing.standard scalar, and we're going to fit it on the training features and apply the transform to train and test. So just go through that, and it looks right. And so now we're going to build a linear regression model. And so from scikit-learn linear models, we get the linear regression method. We give it, really, we're just going to give it one hyperparameter, which is that we're going to not fit an intercept. So that defines a scikit-learn model object, which I'm calling lin underbar model because it's our linear regression model. So I take lin underbar model and I apply the fit method to it to the training features and training labels. So at that point, lin underbar model is trained, okay? And I run that. And it gives me back just a little echo of what I've specified. So copy X is true, which we don't care about. Fit intercept was false. That was my one hyperparameter I set. And we had already previously scaled, so we didn't specify normalizing. And let's just look at the results. Okay, this is a linear model, so it's going to have no intercept, so we'll see what it gives us for an intercept. So these are attributes. We're going to print attributes of this linear model, the intercept and the model coefficient. So here we go. So the intercept is 0 because we said not to fit it. And you see, for each of my features, I have a linear regression or linear model coefficient. So that's all there is to it. It's very easy to fit even very sophisticated models using scikit-learn, because once you have your NumPy arrays laid out for your testing and training features and labels, then you scale, make sure you scale, and then you specify a model object, you fit, and you're done.